So with such a slow time base, guys, you can see the scope effectively goes into roll mode. It's not mentioned in the manual, but effectively that's what it is. So the slow refresh rate is not as much of an issue. I was bitching about that in the previous videos, but in roll mode, not an issue. As most of you guys will probably be well aware that's familiar with the scope, guys, at any point in time during the video I could have long pressed on the run button and actually pulled up the numerical data, so I could have got accurate numbers. I kept the numerical data off screen just in the interest of simplicity, in the interest of clarity of image, guys. So what I have on the drawing here is my electronic throttle control. This is the throttle body itself with the throttle position sensors, 2-channel of course for safety reasons. It is essentially it's a torque motor type arrangement that is actually actuated from this H driver here, which means it applies essentially pulse width modulated or duty cycle controlled power or ground to the circuit, and actually toggles it polarity wise in order to open it or close it. I'm not looking at the actuation side here. I'm strictly looking at the position sensing. So again, it's 2-channel. There's a reason it's 2-channel, guys, for safety, and it is not a duplicate channel. These are ramped up at different rates for a reason. You can see here that it's essentially a voltage divider with a potentiometer in here, and then there's an op amp for that actually drives the signal back to, by the way, this item here is the engine control module itself in order to sense the throttle position sensing. And of course, it doesn't want to see an excessive split between these two signals or there's an issue. Right, so that's only a wee bit of background, and I'm telling you that for context. What I want to show you on the car itself, I've actually got my DSO-153 actually set up here. Let me show you the parameters that I've got set up. It's a 1 volt per division and no attenuation, and I've got a really long time base here, guys, for a reason. Is we're going to sweep the accelerator pedal. It's not the accelerator pedal position sensor that we're looking at here, but the sensing, the 2-channel sensing for the throttle position sensing that we're looking at inside. This is the electronic throttle assembly itself, right? You can actually hear it buzzing, I think, on the soundtrack. I can certainly hear it. So back to the settings here, 500 milliseconds per division, DC coupled, and I'm in run mode at the moment. So let me just get you back to the drawing here again, just for understanding's sake and context. There's a 5 volt supply that comes in on the red line here, guys. The black is actually the ground. Take my word for it, we're all good in that department. We're all good in every department. This is just a demonstration and trying to make you a practical point behind it. So we're going to look at what Suzuki terms the main and the sub channel sensing. So let's take a look at the main right now. So that would be the green wire going to pin 54 if we could see the ECM, but the green wire that goes to the electronic throttle control itself, right? So I've actually already got that pinned there, guys. I hope you can see it. So I'm on the green wire. You can see I've got that back probed at the connector. So my missus is in the car here. She's just going to help me ramp up the throttle position itself. So again, just ramp up the accelerator there, Lisa. So the idea is, guys, to just do this slowly, and you're actually checking for any dropouts, right? So just hold it right at the maximum position, Lisa. So there's the maximum voltage right there, guys, right? So you can see we're about 4 divisions, so about 4 volts here, right? And just slowly ramp it down. The idea is, again, you're looking for any dropouts, which would be synonymous with a failure of the potentiometer, guys, right? And about twice the rate, Lisa. Same thing, about twice as fast. And down. Okay, that's good. Right, so you can see that's a pretty linear increase and decrease there, guys. No issue there, right? Okay. So that was the main. Take my word for it, that is the main on the green wire. And on the other channel, it's actually the white. So let's take a look at this. Keep in mind the DSO-153 is a single channel oscilloscope, guys. Yes, There's two coaxes there, but one is for the signal generator. This is a signal channel rig. That is the heart of this video, actually. Right, let me transfer over here. What are we looking for? White, I think I said. Let me keep you on the scope here. And when I have contact, you'll see it jump up. So I think you can probably see that that's more like 1.6 volts there, guys, as opposed to the other channel, which was up at 1 volt. Strangely, Suzuki has termed the sub-channel. Strangely, the sub-channel actually has a higher voltage on it, which is weird to me, but that's neither here nor there. So we looked at the main. This is the sub. Ramp up the position there, Lisa. And if you recall, the other one topped out about 4 volts, and this one basically tops out about the same. And ramp it back down. Let's see what the base voltage is actually on this. And back to about 1.67 volts ish. I'll show you guys the spec here just so you can see what I'm talking about. So here's the specifications in the manual, guys, when it comes to the sweep on the throttle position sensor. We have the main and the sub channel here, items A and B. These positions here are just referring to that's the default 7-degree position, which we were reading on the bottom end. So you can see here we were in and around 1 volt ish, and then up here in and around 1.6 volts ish, 1.7 volts ish for the sub channel. And then as we sweeped up, it gets to this position here, which is the full open. It's not 100% open. You can manually open at 100%, but electronically it opens to, I think it's 86%. And these were the high-end values that we got here, in and around 4 volts for the two channels, if you recall. Now you can see here, these are actually swept at slightly different rates, guys. Why is that? That's so guys like you and me, if there's a failure on one of the channels, don't just jump the two channels together. And then both channels would be singing the same song. This is intentionally done. Other cars will actually sweep in two different directions. One will climb the voltage and one will decrease the voltage on some other cars. In the case of the Suzuki SX4, they climb, but they climb at different rates as the throttle is actually opened. And again, that's done for safety purposes, done for redundancy purposes, and done to tamper-proof the system as well. You can hear the throttle actuator is actually under control at the moment there, guys. As I said, the engine is not running, but the key is in the run position. The throttle actuator goes to about 7 degrees open is the default position, and that is actually modulated for idle air control purposes. There's no idle air control valve. It's done via the position of the throttle actuator itself, and about 7 degrees from open is about the default position, and it's altered from there as a function of the adaptive strategy that the car is looking for target idle air, right? As this thing gets choked up with a bit of carbon over the years, it opens slightly more, just a wee bit more. But anyway, I'm getting off topic here. So that's the other channel. So great. So it looks like both channels are working. However, the practical limitation of a single channel scope is it's a bit of a bummer that you can't monitor these at the same time. Or can you? We have right now, I only have the single the single probe going to the connector itself, the channel we're interested in, and the other end of the lead actually goes to ground. Well, if we take this off and actually put a probe on it, couldn't we actually go across the two sides of the potentiometer? Couldn't we go across the two sides of the potentiometer here and actually look at the differential voltage? Because we know there is a differential voltage. It's small, but it's there. So we should be able to see it ramp up. The ramp will look different because the split is greatest at the beginning and it will actually ramp down. If you recall, the differential in the voltage was on the bottom end, not so much the high end. So in this case, we'll see it actually start high and ramp down. but we're effectively monitoring the two channels at the same time. That way, if either one has a dropout, we'll see it on the signal. It's a good idea initially, guys, as I swap back to the other pin there, it's back to the main. Leave it on ground so you know that you've actually got the good connection there. You can see it's just under a volt, in fact, the baseline on the main channel. So let me switch this over to a probe as opposed to ground, and we'll go to the other pin. What I have there, guys, is the two leads actually going to both channels now, the sub and the main, right? So what we're reading is the differential across the two. So what I actually said about it going from high to low is going to depend on how you orient those two probes, guys. So it's actually better that I've actually got this backwards to what I had said earlier, because it goes from low to high. But you can see we're actually starting on the negative end of the reference marker for the channel here, right? It doesn't matter. What we're looking for is a smooth and linear signal. So ramp up to full open there, Lisa. And you can see we have a differential of about 1 volt, right? And that's what we actually saw between the main and the sub channel before, was a difference on the low end of about 1 volt. And ramp it back down. And there we have the differential of 1 volt. So the differential is actually on this end of things, guys, right? Now the two channels are swept back to the idle position, if you will, with your foot off the accelerator. Again, the throttle goes to about 7 degrees, but that's neither here nor there. This is basically the default closed position. So this is where the differential is actually greatest, right? Again, the channel marker is a 0 reference, guys. So what we have here is basically a 1 volt differential. Again, I could switch that if I swap the two probes. Obviously, it would go at the other end, but we're not interested in seeing that. We're only interested in seeing the actual linear movement of the trace itself. That way we know there's no issue on either one of the channels. What I can do now is actually, let me change the voltage, since we only have a smaller differential. Then I can change this. Just sweep the again, Lisa. And there you can see a nice, smooth, linear transition between the open and closed position. That is reflective of both channels. Either channel on here with an issue is going to be reflected on that trace. Right, just a little workaround for a single channel scope when you're trying to see two control signals at the same time, guys. I hope that makes sense. That's it, boys. Cheers.